All right, so let's finish off 5.3. All right, so the probability that a randomly selected 24-year-old male uh, will survive the year is 0.9986. I left off male right here. But 24-year-old male will survive the year is 0.9986, according to the National Vital Statistics Report. And they gave other credentials with that, but we didn't need it. So, what is the probability that three randomly selected 24-year-old males will survive the year? What is the probability that 20 randomly selected 24-year-old males will survive the year? All right. So, when you go about looking at this problem, first thing you need to do is ask yourself, are the events independent? In other words, does one 24-year-old male surviving has anything to do with another 24-year-old male surviving?
At all.
Say that again.
None at all.
Right. So are the events independent? The answer is yes. Since they are independent, then we can use our relationship of multiplying the probabilities together. Um, yep. So let's go ahead and do that. Let's see. I'll do purple probability. I'll just say survive. So the probability that a 24-year-old male survives is 0.9986. We got that from the problem. So A asks us the probability that 3 randomly selected people was 24-year-old males will survive. So we're looking at the probability that, let's say all 3 survive. So we're looking at probability first survives times the probability that the second survives. Still didn't make enough room. Third survives. So
You squeeze that one in.
so that means we'll do 0.9986 times 0.9986 times 0.9986, which if you want to write it exponentially, 0.9986 cubed. Of course, you don't have to write that. I'm just showing you, just in case you want to throw it in the calculator that way. And so it's 0.9958.
Can you tell me how you got that on the calculator? Just put it in like that.
Yeah, you can either just multiply it times itself 3 times or raise it to the third power. So if you're talking about this, that's 0.9986. Use that symbol right there and write 3. And that should cube it. A lot of calculators actually have a cube button. You know, they'll have something like that or something, you know.
The reason I said that, I did it on mine and I got 0.9874.
So how did you do it? Did you multiply all 3 of them together or did you cube it?
I did left parentheses 0.9986, right parentheses, and then I hit the x3. The the exponent with third power.
Yeah, let me take a look because
I told you I had issues with my brand new calculator. See, now it gave me the right answer. It gave me 0.958.
Oh, okay. So yeah, that's what I just got. Okay, so we good then.
Man, Barnes and Noble better give me a refund. Something wrong with this. I'm having problems with my calculator.
Oh man.
No.
Well, at least you got the right answer this time.
Yeah, but that doesn't help on tests.
So yeah. So we'll take if you need me to, well, you got the right answer. So I guess what you need to do is
just do it twice to check it.
Yeah, just to confirm and make sure.
Well, I need an outside calculator to check the other calculator, I guess.
Also, see how reliable, just confirm how reliable it is as you do your homeworks, because that will solidify it as well, whether it's good or maybe operator error sometimes.
Okay.
Sometimes we hit we fat finger a button and it occurs.
Gonna say it. I'm old and I don't know what I'm doing sometimes.
Ah, see, there you go. I wasn't even going.
Please stop. I get it though. Thank you.
Not a problem. So the next one, probability that all 20 survive. That's what we're looking at. Probability that 20 randomly selected 24-year-old males will survive the year. And so we keep on with the same pattern. Of course, we don't want to have to write that out. All you would do is take the 0.9986 and raise it to the 20th power. So like I said, you can use this symbol right here to raise something to a power if you don't have certain buttons in your calculator. But raising that to the 20th power, 0.9724.
Now I'm trying to figure out how to raise it to 20th power on my calculator.
Do you see that hat button or carrot? They call it carrot. Sometimes they call it a hat.
I do not have a carrot on mine.
You say you do not?
Mm-mm.
Do you have a button like this where it has a X and then raised to a Y?
Uh-huh.
That's it right there. So you will write in on the 0.9986, hit that button, and then write in 20. Or type in. I keep saying write in, but type in 20.
Well, of course, it gave me the wrong answer, but I get it. I'll check into it. Thank you.
Okay. All right. All right. Questions before we do one more out of this section.
Nope.
All right.
I figured it out.
Okay, cool, cool.
Hit the XY, I have to put in 20.
Mm-hmm. Yeah. All right, so compute the probability that at least one male out of 1,000 24-year-olds will die during the course of the year. If the probability that a randomly selected 24-year-old male survives the year is 0.9986. So here we'll end up using complement rule. So it's easy for us to figure out, like we just did last problem, what's the probability of everyone surviving. So now they are asking us, though, what's the probability of at least one person dying? So that's the opposite. So what we'll do, I can write it this way. Probability of at least one dies would be 1 minus the probability that none die. In other words, all survive. All right. So that's going to be 1 minus, now the probability of none dying is at 0.9986 raised to the 1,000 power, because we had 1,000, at least one out of the 1,000 males. So 0.9986 raised to the 1,000 power is 0.2464. And then 1 minus 2464 is 0.7536. All right, questions. All right. All right. Last section in chapter 5, conditional probability and the general multiplication rule. All right, so here's the notation for conditional probability. If you have the probability of F, then we have this line E that reads the probability that F occurs given that E has already occurred. All right, so this is the way we will compute probability. All right, so this is how we will compute the conditional probability. If you want to compute the probability of F occurring, given that E has already occurred, take the probability of E and F, place it over probability of E, or the number of E and F, place it over the number of occurrences in E. All right, so looking at this table,
I hope all of them 15 years old ain't never been married.
Do that. All right, so there's our chart. Got never married, married, widowed, divorced, and separated. Then for males, 41.6, 64.4, 30.1, 11.0, 2.4. Total is 122.5. Females, 36.9, 63.1, 11.2, 14.4, 3.2, and then a total of 128.8. And then the totals of never married, married, widowed, divorced, separated would be 78.5, 127.5, 14.3, 25.4, 5.6, and 251.3. So we're going to use these values to answer the next question. Questions, I should say. All right. All right, so we're going to use the table to answer these two questions. A, compute the probability that a randomly selected individual has never married, given the individual is male. Then we're going to compute the probability that a randomly selected individual is male, given the individual has never married. I'll give you a few seconds to finish writing. All right, so to calculate the first one, we're dealing with that conditional probability. Notice the keyword there is given. Talking about a person that's never married, given the individual is male. So when we're talking about this conditional probability, we go back and look at the formula. Notice what we need is E and F, either the probability of E and F or the number of E and F, and then the probability of E or the number of E. So let's establish what E would be. Well, the first probability, the first category and the second category. So the first category, we got never married. So let's call it N for never married. And M, given that the individual is male. So what we want to find is the probability of N slash M.
Slash means divide, right?
Well, no, I was using slash as a, for lack of a better word, slash like that would be divide. This is a straight line up and down. Yeah. So it's just a notation that we need to apply this right here. So it's the probability of M, given that M has already occurred, the probability of finding someone who's never married, given that the person you chose was already male. So this chart gives us the number of individuals that fit the categories. So we need N and M, someone who, the number of people that never married and male, and it's going to be over the number of males that we have altogether. All right. So if we go back to our chart, here we have the number of people that are never married and male. So that's 41.6. And then the number of males in total is 122.5. Divide that out, that's 0.34.
You are correct.
Thank you, ma'am. I'll go purple this time. So if I'm not mistaken, this one we have it reversed. The probability that an individual is male given the individual was never married. So we'll keep our same variables. I can write M is male, N is equal to never married. So we want the probability that M occurs given that N has already occurred. So we want the probability of, not probability, sorry. We don't have probability, we have numbers, the number of people that fit that category. So we want the number of people that are married and never, I mean, not married, male and never married. And we already did that. That's that same number of 41.6. And then we're looking at the number of people that never married in total. So that would be over here, this 78.5.
0.53.
You got it. All right, questions before we go to another one?
Nope.
All right, so suppose that 12.7% of all births are preterm. Also, 0.22% of all births resulted in a preterm baby who weighed 8 pounds, 13 ounces or more. What is the probability that a randomly selected baby weighs 8 pounds, 13 ounces or more, given that the baby is preterm? Is this unusual? All right, so let's establish our events. So we got to give the word given right there that lets us know there's an event before, an event after that that we have to give an account for. So baby weighs. Don't do W. We can do W. W. Baby weighs 8 pounds, 13 ounces or more. Given that the baby is preterm, so use P for preterm. So we want to know the probability. Well, let me do this. Probability that a baby weighs. Well, let's start here. Suppose that 12% of births are preterm. So let's start with the preterm. Probability of baby being preterm, 12.7%. Don't forget to convert it to a decimal. So that's 0.12 or 0.127. Next one, 0.22% of all births resulted in a preterm baby who weighed 8 pounds, 13 ounces or more. So this is preterm and weighs that amount. That's 0.22, 0.0022. So that's our given information. All right, so we want to find the probability that a randomly selected baby weighs 8 pounds, 13 ounces, given the baby is preterm. So we're looking at P, oh, should be W given P. So hold on, says weighs, right, okay, I'm good. So weighs given that P already occurred. So the probability of P and W over the probability of P. So that'd be 0.0022 over 0.127. And throw that in the calculator, it's 0.0173. All right, questions on that? And I didn't notate this before, but P and W or W and P, whichever way you write it, those are the same thing.
I got a question.
Yep.
Which one goes? I have a short-term memory
Oh, it's all right.
loss. Which one goes when you divide in the box? Which one do you divide by?
Oh, you're talking about if you were to set up the long division process?
Yes.
Yeah, the one that's on bottom goes on the outside, and then the one that's on top goes on the inside.
Point.
All right. Is that what you were referring to?
Yes, thank you.
Yep, no problem.
Now I don't feel bad. I'm not the only one. They have to break it down a long way. I mean, coming up, we weren't allowed to use calculators in math. Now it's like mandatory in most classes.
Well, I couldn't either. So
You ain't that old.
questions before we do another one. Almost finished with this section.
Nope.
All right, so the general multiplication rule that we have here is just a manipulation of our conditional rule that we had earlier. All right, so this P, and I didn't put an F right here. Probability of P and F occurring is equal to P of F. I say P of F. All right, let me start that over. Probability of E and F occurring is the probability of E times the probability of F given that E has occurred. All right, so the probability that a driver who is speeding gets pulled over is 0.8. Probability that a driver gets a ticket given that he or she is pulled over is 0.9. What is the probability that a randomly selected driver who is speeding gets a ticket, gets pulled over and gets a ticket? All right, so we have, once again, two occurrences here. If you go to your word given, what's the probability that a driver gets a ticket? So we can do T gets a ticket given that he or she is pulled over. UP for pulled over. So if we go back, the probability that a driver who is speeding gets pulled over is 0.8. So the probability to get pulled over is 0.8. Then the probability that a driver gets a ticket, given that he or she is pulled over, is 0.9. So the probability you got the ticket given, they pulled over, is 0.9. So that's the given information. And it says, what is the probability that a randomly selected driver who is speeding gets pulled over and gets a ticket? So we want to know what's the probability of getting pulled over and getting a ticket. So according to the general multiplication rule, I can do the probability of getting pulled over times the probability of getting a ticket, given that I was pulled over. And that'll be 0.8 times 0.9, which is 0.72. All right.
That's it.
That's it. All right. Time is it? Okay, we got time. So there's one more scenario you may see. So we'll do that one and we should be good to go for 5.4. All right, so the first part of this, in the study to determine whether preferences for self are more or less prevalent than preferences for others, researchers ask individuals to identify the person who is most valuable and likable to you or your favorite other. Of 1,519 individuals surveyed, 42 had chosen themselves. All right, so suppose we randomly select one out of 1,519 individuals. What is the probability that he or she had chosen self as a favorite other?
Would it be 41?
Say that again. Would you be 40 what?
40.
You're close. So I don't know if I'm getting all of your statement or if you're fading out. So.
I said 41.
Oh, well, you're still kind of close. No, we got to set up our probability. Remember, this is a probability, so you need a number or something out of. So, our sample space is 1519. Number of individuals who chose self, just call it our event. Oh, you know what? Let's do this. Number of individuals that chose self is 42. So the probability of getting somebody who chose self is just going to be 42 or 1519. I'll write that better. All right, questions on that? Okay, so if two individuals from this group are randomly selected, what is the probability that both chose self? All right. Let's do it like this. So we want the probability that first chose self and second chose self. All right. So we're gonna multiply. Yes, I set myself up to write a lot. That's all right. All right, I'm gonna bring it down here though. So what we're gonna do here is do the probability that the first person chose self. Then we're gonna multiply that times the probability of getting the second person chose self given the first person chose self. So that's what we're looking at. Now, first person chose self is just 42 over 1519. We already discussed that one. Now, this one's a little easier than what we've dealt with up to this point. If the first person chose self, you can ask yourself, well, we know we're going to have our parentheses. How many are left after you pull one out? And that would be 41. All right. And here, how many are left? That would be 15, 18.
Yeah, I told you it was 41.
So, once again, one was taken out. And that's how we got those numbers. Before we finish off the problem, are we okay with that?
Yeah.
They went ahead and multiplied it out and got the decimal. So that's what it gave after that. So my math lab, once again, will let you know, whether they want it in fractional or decimal form. All right, last one. Any questions before we finish it off?
How did you get those 0.007.468?
Calculator. So you just take the 42 over 1519, multiply it times the 41 over 1518. So now if you wanted to convert both of them to a decimal first, you could. Or if you want to multiply across first, you could. Either way, I would be using a calculator. 42 divided by 1519. That's 0.02765. And then 41 divided by 1518. 0.027009. Point 0.027. Yeah. So yeah, if you multiply those together, then you should get that. All right. Questions before we look at C. Make sure we're okay. All right, so compute the probability of randomly selecting two individuals from this group who selected self, assuming independence. So probability of first chose self and second chose self. But the key here is that they are independent of each other. So that means, we talked about that last section, that one probability has nothing to do with the occurrence of the other. So if that's the case, the first one is 42 over 1519, and the second one will be 42 over 1519 as well. So remember, that's only assuming that these occurrences are independent. That means they have nothing to do with each other. And multiplying those together, 0.007645.
Good job. I'm just happy because this is easier than 4 point, that section 4.
Oh, okay. Well, that's a good thing. It's always a good thing when things get easier for you.
I hope so, because I was thinking about dropping class. 4.4 would beat me too bad.
Oh, nah, we can't let you drop. You'll be all right. We're going to make it. We'll be all right. All right. Questions, concerns, comments on chapter 5? Anything out of these last two sections before we close out for the weekend? Next class, I'll open up the floor, see if you guys have any questions as well. That's it for chapter 5. So we are looking to, we'll do a review, so whatever questions you guys may have, whatever questions you may generate over the weekend, and you can ask me anything out of any chapter, any section. So we have 5 chapters under our belt now. So anything you want to go over, whether it be on chapter 4, as your classmate just mentioned, if you want to talk about chapter 4 stuff, how to find correlation coefficient, regression line, whatever, I will leave next class open for you to do that. All right. Oh, we had one. Hold on. I just thought about something. Going back to that baby question. It just hit me. Oh, that was way back there, wasn't it?
Uh-huh.
Here you go.
That was a grown man.
Is this unusual? We didn't answer that question. I don't know what made me just think about it.
Yes, it is.
Yep. So, is it unusual? Yes.
Yeah, I was right. See?
Because
nobody should birth a grown man.
Probability
This is
is less than
I'm smart.
0.05. So remember we were talking about, this was our probability, 0.0173. Remember we mentioned, might be a couple of chapters ago now, wherein if something is unusual, then it has to be, that marker that we have is 5%. So if something is less than 5%, it is considered unusual. So yes, it is unusual.
There's hope for me.
All right. So anything else before we close out? All right. So with that being said, everyone have a great weekend. Be safe. Like I said, like I mentioned, next class, I will leave the floor open for you guys to ask whatever you want, no matter what chapter we covered, 1 through 5. If you got it, bring it to class so we can talk about it. And we'll go from there.
Have a good weekend.
All right, you do the same.
Did you, Mr. Tucker? Have you sent the last couple lectures in Zoom?
Hold on a second. Let me go to stop this recording real quick.